All right, guys, so today we're going to be looking at complex fractions. What this does is pretty much take everything we've been doing with operations of rational expressions and puts it all together. So let's just jump into it. A complex fraction, it's just a fraction in a fraction. So think about this middle fraction bar is really just a division bar. So we're dividing these two rational expressions. Always a good idea if you simplify first, if you can, in the numerator and the denominator. I'm looking, nothing simplifies, so then I'm going to go ahead and multiply by the reciprocal here, since this is a division. Remember, fraction is just division. So I'm dividing this first fraction on the numerator by this fraction on the denominator. So I'm going to rewrite it. A over 2, don't change that one, and we reciprocate the second fraction. Now, before we actually go through and multiply, simplify. So I'm looking, a and a squared, well, that's 1, and that's 1a to the first power. 2 and 4. 4 divided by 2 is 2. 2 divided by 2 is 1. So now I'm going to multiply. 1 times 2 is 2. 1 times a is a. Moving on along. So we're just going to do a bunch of these examples. If it's just monomials, it's really nothing to it. Again, that middle fraction bar there is just a division symbol. So nothing simplifies, write it out. Multiply by the reciprocal. Again, simplify before you multiply. There are no y's in the numerator, so I can't cancel any of them out, but I do have x's. I got 3 up here, so if I divide x by x, I get 1. X cubed divided by x is x squared. Write it like that. What am I left with? Nothing else cancels. 2 times 8 is 16. X squared over y squared. That's it. Nothing else we can do with it. Leave it alone. Now we start getting to binomials. So as you can imagine, we're getting to factoring. Factoring's not going anywhere. We've been doing factoring for months now. Get used to it. I'm looking, I could cancel out a 2 here, but that would require me doing GCS. So I think I'm just going to hold off on that. If this is a binomial, I'd definitely factor it first and see if I could cancel something. Let's just go with it. Let's see what happens. So P. So like I said, I could factor out the GCF here first and cancel, but I'll do that in the next step. Reciprocate. Any squares? No, okay. So if we look, it doesn't look like anything cancels really, except maybe this 18 and this 4 over here. But if we notice, there's a GCF here. Factor out that 2. Oops. Now let's do some canceling. So 18 divided by 2, well, that's 9, and that's 2 divided by 2 is 1. 4p minus 1 divided by 4p is 9. 4p minus 1 is gone. That's 9p. Oh, nope. We got these p's canceling. P divided by p is 1. P squared divided by p is p. So we've got this 9 on top. And on the bottom, let's see, we've got 4 times p is 4p. 9 over 4p. So you could have factored out the GCF here. That would have been fine. I just wanted to demonstrate it like that. No particular reason. Moving on. Okay. Let's check this one out. Again, nothing canceling. Let's divide. K minus 1 over k times reciprocate. And I'm going to go ahead and this time I'm going to factor as I go. It's the difference of squares, k minus 1, k plus 1. So you can write it out, then factor, or factor while you're writing it out. Your choice. But if you get confused easily, Write it out in factor. Those cancel. I divide those, I get 1 and I get a k. I'm left with k over k plus 1. And no, that does not simplify any further. You cannot say k divided by k is 1. That does not work like that. Don't try and do it. This is the binomial on the bottom. Leave it alone. All right, now we got a trinomial. How do we do trinomials? AC method. So this one I'm definitely going to factor first because I'm wondering maybe that b plus 2 might cancel. Let's find out. So I'm going to go ahead and factor these things. Now you can do scratch work. You can do it in your head. I don't care. Top part's b plus 2. That's not changing. Over. Now this, that's b plus 4, b plus 2. How did I get that? Oh no, wizardry. AC method. 1 and 8 makes 8. 6 as well. 6, factor that. 4 and 2 add to 6. Put those over 1 because that's what A is. 1 b plus 4, 1 b plus 2. Oh, hey, look, they do cancel. Times, and again, I'm going to reciprocate that and factor. I'm going to do this one in blue. So let's see, it's something over 1. Let's see, b, okay. That's a negative 20. We get a negative 1, so that's a negative 5 and a 4. Goes over 1 because that's what A is. That's going to factor as 1 b minus 5 times 1 b plus 4. And now let's cancel some stuff. B plus 2's cancel, b plus 4's cancel, and all this simplifies down to b minus 5 over 1, which is just b minus 5. Done. Next up, here we go. So I've got a GCF and the AC method on this one. So I'm going to do the GCF now. Yeah, let's just do the GCF for now. Write it out. This one is the same exact one we have right here with a different variable, so we should know how that factors, but we'll just write a whole other step for it. GCF here is 3, factor it out. Take a look at the other side, reciprocate it. On the numerator will be this, it has a 9m as a GCF. That's going to be m plus 4. So I just factored this right here as this right here. The denominator, they have an m squared in common. And look at that, stuff's going to cancel. I'm going to go ahead and use the AC method on this. In my head, since I just did it. I'm not going to bother changing this one yet. Now that I have it all factored out. Let's cancel. M minus 5 and M minus 5 cancel. Pick an pick an M plus 4. Eeny, meeny, miny, doesn't matter. Cancel it out. 9 divided by 9, or 9 divided 3 by 3 is 3. Oh, shoot. 9 divided by 3 is 3. 3 divided by 3 is 1. Okay. Bleh. We got an m here, an m squared there, so that's an m. That's a 1. Anything else? Anything else? I don't think so. 2 times 3 is 6. M plus 4. Bottom, we got an m. That's it. Done. Move on. So this can get time consuming, but we'll see that on this particular problem right here. Okay. Notice we have a subtraction problem in our denominator. Guess what? You have to subtract them first. Then combine like terms, then factor, then simplify, then divide. Okay, just do it all. 5 over 4 stays just 5 over 4. Sure, why not? Can't do anything about it. This thing right here. I'm not going to do the times yet. Let's say it's divided by, now right here, that has a GCF of 4 and minus 4. So my LCD is 4 and minus 4. So this guy's missing a 4, so that's 80. I'll write it down. Okay. So here I'll do some scratch work with the denominator only. Okay. So this is missing the 4 right here. So I need to put it. Now it matches. Now we have the common denominator. But to do that, I have to multiply my numerator by 4. Done. That's going to make 80 minus 5 over my, that looks like an 8b. That's 80, 80, over our common denominator of 4 and minus 4. Okay. So that's what I'm going to put over here. And divide it by, well, 80 minus 5 is 75. Over 4 times n minus 4. Remember, that's just division. That's all a fraction is division. So now we're going to reciprocate it and multiply. When I say multiply, I mean factor and cancel stuff. 4s get out of there. 5 divided by 5 is 1. 75 divided by 5 is 1 and 5. And it looks like we're left with n minus 4 over 15. Leave it like that. It's perfectly fine. Okay. So nothing too terrible right there. Let's see the next one. Okay. Again, we're going to have to do some scratch work. See this denominator of 1 right here? We need to be w plus 2. Well, obviously our LCD is w plus 2 because our other denominator is 1. So w plus 2 times 1 is w plus 2 minus w over w plus 2. What happened? I'm just looking at the denominator here, just the denominator. 1 over 1, well, I need to multiply that by our denominator, LCD, w plus 2. Do that to the top and the bottom. Do that, that's 1. Nothing changes, no value is changed, just changes what it looks like. If we do that, we get w plus 2 over w plus 2. Common denominator, so we can just subtract that w. So now, I'm going to write down my first term, my numerator, whatever you want to call it, factor, I guess. Yeah, factor. Divided by, so I'm going to multiply by the reciprocal of this. I'll write it as division first. That'll be too much in some of your heads. So if I simplify this, that's 2 over w plus 2. Now I'm going to reciprocate. So if you're able to see what's going on, you can reciprocate in this previous step. I just wanted to write it out in case some people had trouble seeing it. Cancel stuff. We're left with w over 2. Done. Okay. Oh, too far. Okay, there we go. There. Now, I've got subtraction in the numerator. I've got addition in the denominator. I got to do it both. So we're going to do a lot of scratch work first. Let's look at this numerator. Common denominator is a squared b squared. What's this one missing? No, I'm missing a b squared. What's this missing? An a squared. So I'm going to rewrite the numerator as, well, it's b squared, b squared minus a squared over a squared b squared. That's my common denominator, right? Over. Now let's do some scratch work with the denominator here. LCD is AB. I mean, hopefully you can see that. This is missing an A, that's missing a B. That's going to be A plus B over AB or BA, whatever you want to call it. AB. Alphabetical order, why not? So we rewrote this one as two fractions. Okay, we got a common denominator. We subtracted these. Now we need to reciprocate and multiply. So I'm leaving my numerator alone, except I'm going to factor it. That's the difference of squares on top. B minus A, B plus A for the B squared minus A right there. Over A squared, B squared times the reciprocal here. AB over A plus B. Yeah, I put it in parentheses just to make it easier to see. Oh, hey, these are the same. Get it out of there. Let me do a different color. Get out of there. A divided by A is 1. A squared divided by A is A. B squared divided by B is B. B divided by B is 1. I think everything's gone that can be gone. So we got B minus A on top and AB on the bottom. Nothing else we can do there. Leave it alone and move on. Okay, so we got some ones here. So again, lots of scratch work. Multiply that by n over n. Multiply that by n over n. So that's going to be m minus n over n. And the bottom is going to be m plus n over n. Follow me? N is my common denominator. I'm just subtracting them. They have this common denominator. N is my common denominator. I'm adding them. They have n as the common denominator. So that's going to be m minus n over n times the reciprocal. And all we can do here is cancel out those n's and move on. Yep, so one more. It's a doozy. So if we look at the top, the numerator, we're going to have to factor out that 5 in this second term's denominator of the numerator. Yeah, that's a tongue twister. So, you know what, I think I'm just going to rewrite this whole numerator here. A squared, A plus 3 plus 5 times A plus 3 over A squared. Under A squared, I guess. Sorry. Yep, that's the numerator there. The denominator, well, I'll just write it down. Now let's look at it. This guy's missing a 5. That's not going to multiply by. Now we're good. This guy's missing a 5. This guy is missing an A plus 3. So now these will be common denominators. Those will be common denominators. Let's put it all together. 5 times A squared, that's 5A squared plus A squared over our common denominator of 5A plus 3 over 5 times a is 5a plus a plus 3 over 5. Parentheses there. Sorry, that was my fault. That needs parentheses. A plus 3. Combine like terms. I'm going to go ahead and combine like terms and reciprocate it, okay? So we can move this over a little bit. 5a squared plus a squared is 6a squared over 5 times a plus 3 times 5a plus a is 6a. Well, we're reciprocating. So this is going on top. If you need to do it in multiple steps, that is perfectly fine. Not canceling yet. We have a GCF here of 3. Technically, yes, you could go ahead and simplify it with the other pieces, but let's just factor out the GCF first and cancel all at once. Take your time, do it piece by piece, and you'll be all right. Okay, I factor out a 3 out of there. I was left with 2a plus 1. Now let's cancel some stuff. 5 and 5 cancel. A plus 3 and a plus 3 cancel. 6 and 3 cancel. That's a 2. That's a 1. Those are 1s. So let's see what's left. On top, we got a squared, 2 of them. On the bottom, we've got 2a plus 1. Done. We're finished. Haha, victory is ours. So yeah, nothing really new here, just a lot of it shoved together. So if you didn't master the operation with rational expressions last week, you better master it this week. See ya.